output voltage, okay, at 230 no matter the changes of the load, right? So in order to achieve that, because just now I can see some of you will have a very funny output here in the beginning, or that is because the power deliver and your calculator LC, okay, doesn't fit during that time. Okay, in order to do that, okay, we will need to have a feedback control. Now, if you look at this, I'm not sure is it familiar with you. If it's not, maybe I will show you again what you all see in your control system class. Your control system class will show you a reference, right? Coming in with a circle where plus, minus, going out. This is your PI controller, and this is your plant. Okay, this is your plant that you want to control. And then the output of your plant is actually feedback, okay, to the reference. So in your control class, you study the PID controller here, and this is your plant. Okay, so this is the basic, what we call feedback control. Okay, the plant can be represented by S over S plus 1, the Laplace or S domain, right? And then here, you need to set the Kp, okay, and the Ki value and the Kd value, so that you will achieve, okay, the desired control output. Now, the same control principle you have learned in control theory is actually applied in many of these power electronic converters. So one of it is here. Okay, if you look at it, VRAF, this is the reference voltage. Reference voltage means that, okay, the voltage you want the inverter to maintain, okay, which is 230 volt. So it minus the feedback and it go to a PI controller. Now, in power electronic, we do not use PID. We use only P and I. Okay, we only use P in proportional and integrate, okay, slowly to achieve your desired output. And then, now the whole thing here, okay, if I cut this out lah, so this is the controller part, the Kp and Ki. And then this part here is the SPWM modulator, which is also part of the controller lah. Okay, so meaning the whole thing here is the controller. Okay, it's the controller. And of course, the inverter. Okay, this inverter consists of what? Consists of 4 switching diode, full bridge, plus the L and C filter. Okay, so this one is representing the plant. This one representing the plant. So that's why just now I show you how this L and C, okay, can be represented by the S domain. So this is the plant, and output of the plant, you can see there is a feedback, and it goes through a RMS because the output here is sine wave ma. Now we want to measure the RMS, so after this one, it just become a DC, right? And then this one minus the set voltage of 230. Okay, then it repeats itself until it achieves the desired voltage. So that with that, right, you can actually set your inverter. If you are using in Malaysia, you set the V reference is 230 lor. If you're using US, you set it in as 120 volt lor. All right, so this is to help the inverter, okay, to control the voltage output. Now, how to write the equation? Okay, this one is also important. Okay, just to know that if you are given a control block, how do you derive equation from the block? Or I give you the equation here. By looking at the equation, you should be able to draw the box. Vice versa. Okay? So first of all, the E is the error here. E bracket T. Okay, draw here better. The E bracket T is the error, which represent V reference minus V out RMS. Okay, at this point. And then the GT, okay, the GT here, the control output, will be the whole output GT will be the KP, okay, the KP multiplied by this, your error, plus, because of PI, okay, KI is integration, okay, KI is integration multiplied by your error. So this represent the PI controller. Okay, represent the PI controller. And then multiply by sine omega t, which is represent by this set here. Multiply by your sine reference or sine omega t. So that you will construct, okay, your feedback control. You all looks very lost. You all learn this in control, right? Huh? Okay. Oh, at least I know you all know what I'm talking about later, you know. Okay. Again, this important because the rest of the class, be it DC-DC converter, we will use a lot of this feedback control. It has to be there. Okay. It has to be there to maintain power converter control. In the previous example, there is no control element. Okay. But this one got. Okay. Now, how do we implement this whole thing into our this what we call inverter? Now you already done this, right? Now just now we don't have feedback. You can see the difference. The feedback is here. The feedback is here. Okay. So now what we need to do? Okay, we want to set this is our V reference. V reference is here, 230, right? And then plus minus. You want to minus the feedback, right? Minus the feedback. The feedback is going through RMS. Okay, so it's going through this RMS. The output of the RMS go back all the way here minus. Because just now without feedback control, you will notice that our voltage here, right, is not exactly 230. Okay, it's 225, something like that. You cannot get exactly. So in order to solve this problem, we need a feedback control. Okay, we need a feedback control. And then after this one, you go through the PI controller. There is a PI controller in Simulink. Okay, the PI controller. then the output of the PI controller is multiplied by your reference sine wave. Okay, your reference sine wave, this is the one that we use, right? And then the rest is just SPWM, SPWM, okay, and then connect. So this is how we add, okay, up to this part. You see, this is the PWM blocks. You look carefully, the whole part here is exactly the same here. The whole part here. See, you must know how to relate them, okay, to a Simulink. I mean, you know, this is what we see on control design. If you are given a Simulink, you should know how to do that. Okay, so to do that, let me just show you the demo. Okay, so this is the demo, all right? Okay, the rest should be the same. I'm using 10K. Okay, and then this one, the sinusoidal reference is, you know, 1, and then 2 by 50, no change. And then this is just a constant blocks. The trick is the P and I. Okay, the P and I blocks okay, maybe I show you when you put in, it looks different. Okay, the PID blocks is inside the continuous, Simulink continuous, and you see there is a PID controller. You drag the PID controller here. Okay, when you double click. Okay, first of all, you change the controller from PID to PI only. Okay, change from PID to PI. And then after that, you set this. Okay, this one, how to calculate and set, we will discuss it later lah. Okay, so you set 0.001 for P and 0.15 for I. And then for output saturation, upper limit is 1, lower limit is 0. Okay, you have to set the output limit. Originally, right, the PI controller, there is no limit output. So it will go all the way to infinity. Then you will see a very funny output later. So these are the two things you need to set properly. Okay, you need to set properly. So if everything is okay, you run this. And you will see that your voltage will slowly go down, go up and achieve, okay, the desired output. Okay, now you will see this happening, right? But it's okay, it's normal, because your feedback control try to track the voltage slowly until it reached, okay, the 230 watt hour, which is 325. Then it becomes stable, all the way stable down. Okay, and this is the voltage, all right? Then if I change this to, let's say, 120. You see, when I set here 120, right? My output also 120. So that's why you will see those inverter that help you to set, okay, you are in which country, which region you can set. Okay, so you can see if you don't using any feedback, the water is fixed, you cannot set. So this is how you control. Now you can see, now I can bring this to US. So I can still use it in US without changing a new inverter. It's just a setting control here. All right. Okay. Okay, maybe I'll go through a few examples. Okay, while you all can start doing this because almost 9:30 already. Okay. Oh, this one is a real converter. Okay, I think this one next week already lah. All right. So yeah, please do this. Feedback is very important because DC-DC converter you're going to use a lot. This one, right? This one is a subtract. Okay, you may say, sir, where to find the subtract? Okay, the subtract you can find in the maths operation. You got add, divided, all this, right? Okay, there is a subtract. Okay, subtract is here. You can use this one directly lah. If you, okay, subtract, you bring here, you can use. And how to change to the circle, double click, you just change round lah. Of course, you will see, oh, the point is not right, right? This one you need to play around already. I also forgot already. I think this one I need to put a vertical, something like that, so that it will change. It will become like that. Okay. Change to round. This one put a vertical line in front, then it will change to this shape for you to do the minus, like in the control theory. Any questions?
Sir.
Yes.
Can you show again the PI value?
Okay. Wait. 0.001 for P, 0.15 for I. Saturation, okay. Make sure you set the limit. Maximum is 1 over 0. Everything is correct. You should get 230 watt output. Of course, you can set 100 watt. It also can. Like you bring this to Japan, you set 100 watt. Then next week, I think we will be finished single phase already. Hey, cannot still got click connected leh. Oh my goodness. Oh. That's why 14 weeks when got enough time. Really want to teach everything. Okay. Okay, let's see those online. Wow, beautiful. Wait, suddenly so many of you. This one no PI control eh. Oh, they Pun Hong. Oh, okay. Eh?
So my runtime is 0.1, so it become 228. But if I enlarge to 1 second, right, it become 230.
You put like 0.3 or 0.4, not enough time for him to get to the setting.
Okay.
Yeah, important your runtime. If it's too short, you won't be able to reach that. Your THD 0 means good lah. Yeah lah. Hey, but very strange it should be 0 point something lah. Don't know what's wrong. Well, okay lah, you get low THD is what everybody looking for. And the most important thing now is the feedback control lah. Okay, so okay, I think it's almost time already. We will stop here for today. All right. Like I said, please continue to practice. Okay. To practice this what we call the exercise at home. Let me try. Okay. Your THT 0, I'm not sure. Okay. It shouldn't give you exactly 0. All right. It's 0 something. Okay. It could be, I don't know whether it's your THD setting or your time. But anyway, it's it's good news that you get 0 because that means you have a perfect sine wave lah. But just bear in mind that in practical, this is not possible. You still have 0 something. Okay, so try to play around with different voltage. Okay, good work, Ko Sing Yi. Okay, Fu Tun Hao. Okay, Fu Tun Hao. You 0.1 too slow lah. You break it longer a bit. Otherwise, you see, you just get 227 and it's still not reaching your setting. Yes.
I want to ask if let's say we choose the wrong resistance value, then after we use the feedback.
It affect less.
Less.
It still affect, but not much. Without feedback, it affect a lot.
Oh, okay.
That's why we need a feedback control to make sure if you change the voltage also, it won't affect much.
Oh, okay.
That's why you have to try this side, then you will see the difference.
Just now we try, if we use different system value, then it's still
Yeah.
the
That's why the feedback control is very important for these power electronic converters. Yeah. Okay. So before we wrap up, like I said, feedback control is very important for power electronic converter, not only DC to AC. Okay, and please try to make yourself familiar with this. And I believe when you all study the control system, you will look into the basic principle. So now I will bring the basic principle into more specific applications, okay, for this what we call power electronic converter, so that you can appreciate the feedback control, PI control, all right? There are actually more complex control at the back when we go to grid connected. Don't worry, I try to simplify as simple as I can, and also I also worry about the time. If I keep on talk about, DAC itself, this one I can talk until end of the semester, but time not allowed. So I will stop after I talk about three-phase. Then I mean move on to a new converter already. Because this Power E, like I say, most of the advanced Power E they are actually put in master courses. When you study master in electrical, you will have another like advanced power electronics. Then we will talk more what we are missing here. Now undergraduate, because I also need to take care for those mechatronics students who are not specializing in E and E, so they just need to know the basic. All right. Okay. So if no question, this one a bit of overshoot lah. Maybe you need to fine tune a bit of your PI controller, huh? Matthew Lim. Okay, so almost okay. I think I need to leave the class already. So if no question, we have to end the class today. All right.